human impact archives. So I added also human impact because also it's important, especially in the last few decades or 2 centuries. Human has a great footprint on our planet, locally, regionally, even continentally. I work in geomorphology, so I am dealing with landforms, especially in the mountains, in the mountain environment. My PhD was about the glacial cirques, all the glacial cirques in Romania. So it was a lot of work. So I'm very, you know, I was very easily for interpretation the glacial landforms. After my PhD, I started to pay attention to the lakes and for the lake sediments, especially the glacial lakes, but not only. So I work for environment geography, limnology, paleolimnology. Okay, today we discuss a little bit about the lakes and the lake sediments, limnology and paleolimnology, which is the new trend in limnology, which also belongs to hydrology. And my examples will be based on Romania, especially around my university, which is located in Bucovina. It's a northeast of Romania. It's a very nice region. It's mostly Carpathians, but also a little bit of Moldavian plateau, but mostly Carpathians, not very high. We have mountains which range between 1,000 and 2,000 meters, even 2,100 meters. So we have glacial landforms, landslides, a lot of slopes, and even volcanic in the Bucovina. So it's a very nice region, and you are very welcome to visit our university, which is tiny, modern one, and very well equipped. Okay, let's go. We talked just a little bit about limnology. I'm guessing most of you are from geography department or environment department. And then we step out on paleontology and paleontological approach. Just a little bit about the interpretation of the paleontological indicators, because we are dealing with this very much in order to recover, to discuss about the climate signal from the past. Lake samplings, which is very, very important, is a field stage, and then laboratory methodology. This is also very important, and it depends a lot of facilities, funds, and support, because they require quite a lot of equipment, and some of them are not very cheap. Lithostratigraphy, which is dealing with the sediment profiles. We can look inside and can see how the geology or lithography looks, and then geochemical stratigraphy. It comes from the laboratory methodology with a lot of methods, and then we talk about a little bit about the isotopes. Anyway, this direction, paleolimnology, because it's a window to the past, we need to use some isotopes in order to put all these events and or changes or impacts on the time scale. And just I mentioned two of them, which are very well known. They not allow us to go deeply in the past compared with the carbon 14, but these are important for geography methods. And then the last and not least, few things about the glacial lakes in Romania. As you know, limnates comes from the Greek language and means lake or pond. Limnology actually is a study of inland waters. Could be running waters or stagnant waters, which we call lotic and lentic, but mostly stagnant lakes. And the first actually book about the limnology was the Oceanography of the Lakes by the Forel in 1892. A Swiss man who talked about Le Mans Lake, which is a glacial one. And then if you If you ever study hydrology, you must know these guys, Evelyn Hutchinson, which is the father of the modern ecology. Hutchinson was the one who classified all the lakes over the world. Even today, after many years, we still use this classification in our books, our presentation for students, because it's very comprehensive classification for all the lakes over the world. So he is the father with this treatise on limnology. Limnology, it's interdisciplinary terrain. Everybody from biology, geology, geography, physics, chemistry, they are interested in limnology because it's a field with a lot of interest. For example, we can talk about the biological limnology, which means that biologists are interested in the life within basin, within the lakes. So they are looking for vegetation or fauna. Geography, for example, we are interested in formation of the basin, of the lake, and also we are interested about the water, the level, the volume, the balance, temperature, pH, everything. Chemistry also are interested in pH and transparency and you know, different oxygen and so on. Geology also, geologists are interested in formation of the lakes and also in the sedimentology. So, but all together with the geographers and biologists. So this is why we call this domain very interdisciplinarity. So you need some skills from different fields in order to deal with the lakes, at least when you go deeply inside, especially on the sediments. Limnology means a lot of things. So it's dealing with the origin of the lakes. So starting from tectonic lakes to the glacial lakes, for example. Morphometry, we like to measure the lakes and make classification, to talk about size, about depth, about shoreline and so on. It's about light and heat. Also, it's important for the biologists. We are looking for the fauna and the vegetation. Water movements also is important for geographers. Big lakes have tides, waves, currents, and even upwellings and downwellings stuff on the one, and balance, for example. Oxygen, salinity, sulfur, phytoplankton, zooplankton, fish, shallow lakes, and paleolimnology. This is the new item which comes on the limnology. So I started to work on paleontology maybe more than 10 years ago, and I found this very, very interesting. So now we discuss about the paleontological approach. First, paleontology is a new entry in the limnology, and we use lakes, and especially the sediment in the lakes, like very important paleo records. We can't, we don't have instrumental data from 200 years ago, 2 million ago, or 2,000 years ago, because we didn't have any possibility on that time. So we should use these sediments. We see these sediments in the lakes like an archive, it's a natural archive. It's like a book, and indeed the sediments settle down like pages, one by one, year by year. So lakes and the reservoirs are human-made, acts like sentinels for climate and ecosystem change. Similarly, and in the same direction, the same register, paleoecology is also important because study organisms and their environments in the past. If, for example, we like to find out about the precipitation or temperature 1,000 years ago, we need to find remains of this organism and the sediments, and then based on type of organism, we can say how the temperature and the precipitation at that times. For example, if you find, you know, some pollen from oak, for example, oak, yeah, you know, it's very, very common tree in Europe. He survived during the glaciation. He survived very tiny area, especially in the southern Europe. When it was very cold in Europe, they stayed somewhere in Greece, in southern Italy or Spain, and they survived this walk and then come back when the climate was warmer and warmer. And if we find in the sediments pollen from the walk, we can see, we can find out how was the temperature and precipitation on that time, based on the temperature and precipitation that walk likes today. Okay, it's very simple. So it's paleolimnology and paleoecology are very close and stay one by one side. So excellent sentinels for change, for changes, for climate change and human change also, because in the last 2 centuries we have a lot of evidence for human impact in our environment. It's actually it's like our science, and we will find out about that. So there are also natural archives for the past environment changes, both from the biotic and abiotic components that we can find in the water, especially in the sediments, which comes from inside the lakes, outside, just in the basin, and even from the local or regional signal, because you know the wind can spread spores or pollen and put in the lakes. There is a very nice connection, and it's like that definitely, between lakes and hydrological cycle, because the lakes belongs to the hydrological cycle. Doesn't matter if it's a big one, like you know, big lakes in North America, or the tiny one. The lakes, it's like litter storage on the way where water, you know, it's running off for the big peaks to the sea. So this is it's like a refuge. It's like a little, you know, time to rest of the water in these lakes. But in our case, and everything that water collect from the environment, in the air, on the terrain, all this information are put it in the lakes, on the in these layers. And this is very important for us, because lakes actually represent sediment traps. Because if you compare with the rivers, they can't keep the sediments. They can do that time to time by flooding on the side or another side, but then another flooding comes and it's not continuous, and then erosion comes very easily and destroy these archives and so on. And this is not happening in the lakes, because in the lakes any layer is deposited year by year, and it can't be removed from there. The sediments are trapped, and if you think about the lakes now, they are, you know, they contain water, they contain energy, they contain sediments, they contain fauna and vegetation, but they also contain information. This is important. They contain a lot of information, and this information comes from the atmosphere. Everything that we have an atmosphere, from particles, from pollution, isotopes, ash from volcanic, from industry, from your car, everything which are flying in the atmosphere on a certain time, they are depleted in the lakes. So we have inputs from atmosphere. We have inputs from basin, because as you know, every lake, like a river, have a basin. So everything happened in the basin: deforestation, agriculture, fertilization, and so on, human impacts in any way. Everything that happened there, or any disturbance or undisturbed disturbance, this information comes to the lakes, especially by erosion. This is important. So mineralogical or organic stuff comes from basin, from the erosion of the rock and the soil, they come together, and they also take the information. If the erosion is big, something happened in the basin of deforestation or intensive agriculture. If the erosion is low, then the basin is stable. But this also depends on the climate. If the climate is stable, it's okay, it's optimum, then we have a very low rate of sedimentation. If we have a lot of strong events, like extreme events in the basin, and it comes from the climate, and if you compare, if today we have something like that, then erosion will be bigger and bigger. We have information within the lake, because we have a lot of life in the lake, and any kind of this life, after the death, they deposit on the sediments, and later on give information about the temperature of the lake, the temperature in atmosphere, depends of the organism, and even from the ground, underground, by water circulation. So keep in your mind this very important indicator for the lakes. They are sediment traps. Actually, lakes are like a system. A very nice geologist, an American geologist, compare the lakes with a microcosmos or micro-universe, because it has a boundary, like a basin, and it has energy and a balance and so on. It's very important to keep in mind that they are natural archives, and they record information about the climate and environment changes. And pay attention from this point, that you need to respect and restore and to protect the lakes, because the lakes are like libraries. They keep information for us. Also, lakes means a very good quality of water. Lakes means beauty. Everybody wants to live around the lakes, and lakes inspire artists in any way, and this is important. They record signal on the local scale, yeah, let's say around your town or in a village or so on the regional scale, like in Bukovina, and sometimes, and we discussed about these possibilities, they can record on the continental scale. They are very sensitive. They are not like glaciers, because glaciers respond very, very sharp, very abrupt on the climate change, as you know, from the television, from Discovery, the glacial retreats. But they are sensitive also and record any changes. And there is a lot of a big variety of analyses that we can do on the lake sediments, physically, chemically, biologically, and pay attention on the control factors. Anytime when you study a region, anyway it's big or more or less or small, you need to pay attention to the control factor. In our case, pay attention to the geology, because geology is important, and they talk about rocks, about tectonic movements, and so on, even volcanism. I can explain you why you find volcanic ash in your sediments. And geology stability is important. Pay attention on the climate. Climate also, it's the big factor control. And later on, pay attention to the human impact, because human impact has a lot of implication now in the paleo-environment records. All of this information comes from outside. They are allogene, so from atmosphere, from the basin. They are from inside, endogene, within the lake. Any time on the lake are facing changes like water level or water temperature, organism, vegetation changes, and we can find that in the sediments. And even autogen, which means they are within the sediments after they deposit. Climate change, it's a new topic, at least for the last 2 decades. It's a big challenge now over the world. So this is why we are interested to study the past climate, because past climate could be a key for the future climate. Past climate can provide us a lot of answers for our questions: when, how, and so on, why these changes happened. And we know that these changes are sometimes, most of the time, irreversible. So we need to pay attention. We need, at least on this time, we use 3 types of data for paleoclimatic reconstruction. So we use instrumental data. This is monitoring that we are doing every day in the meteorological station, hydrological station, and so on. And we use data from the documents, even from archives. A lot of documents, people, even from medieval time, they noted a lot of things about nature, about rainfalls, earthquakes, about the grapes, when it was harvest for the grapes, and so on, which are very important for us. And we are talking today about the proxy data, the data that we need to take from the proxy data environments like lake sediments, speleothems in the caves, tree rings, or ice cores from the Greenland or Antarctica or Alps, and so on. So all of these are proxy data we are talking about. And in our case, we talk about the lake sediments, our micro-universe, because everything are recorded by the lakes, everything which comes from the atmosphere and from the basin, within the lake, even within the sediments. So every information are very well kept in the sediments, and then we can decrypt this information and find out what happened in the past with the climate change. So everything like pollen, minerals, insects, flash, carbon particles from our cars or for industry, they come to the lakes finally, and even with the precipitation, with the isotopes, because they are everywhere in the atmosphere, because there is a lot of fight between photons and protons, and they are providing these isotopes, and they finally are deposited in the lakes. And everything would happen within the lakes with the zooplankton, phytoplankton. They finally, after they die, they are deposited in the sediments, and depends on them, we can find out about conditional environment in the past. We need to take samples, and we work with the resolutions. We need to have a better resolutions. Usually, over the world, let's say that the resolution is around 50 years, maybe 100. So it's a secular resolution, but 50 years it's one of the best. We try to have better than that. So, for example, in this case of 50 years, we have a layer that can provide information about 50 years. This is the resolution for the lake sediments. We like to have annual resolutions, like we have in the VARF, annual layers, which is 1 year for one layer, but these VARF layers are very rare. This is for glacial lacustrine or glacial fluvial lakes in the northern Europe, especially in the Scandinavia, and you can see layers very easily, and each 2 layers, because they are seasonal, means 1 year. This is the best that we can have in the VARF sediments. Is like the same like tree rings, but most of the lakes that they are a lower resolution, especially around 50 or 100 years. Paleo-environment data, it's the ones who are derived directly or indirectly from the geochemically and biological process, and we talk about that. Without sediments, we can't have any information about the climate or environment changes 1 century or 1 million, 1,000 years ago. We can have data from monitoring, from hours, days, seasons, years, decades, maybe. For example, we monitoring the air or water around 100 years ago. But for paleoecological or paleolimnology, we need data from centuries and millennia. And we talk about a lot of years here. We need this environment data. It's very important to assess the background, like a reference. Reference conditions usually is the health state of an ecosystem, especially before the human disturbance. And this, we need to know how was the ecosystem or environment or climate before the human impact, and to assess the range of natural variability, which is climatic variability, hydrological variability, and so on, and to ask to our questions, especially today. Have conditions changed? Yes, we know that. How much, how fast, when, and what was the cause? And this is very important, because without these answers, we can't have a projection of the future climate. So paleolimnology, as we stated at the final of this presentation, it's a window, it's a door to the past for a window to the future. Before to talk more and more on paleolimnological approaches, we need to know from the beginning that we are on this approach. We are based on the uniformitarian principle, by which we expect that any present day process behaves similarly in the past. So the sedimentation, it was the same 1,000 years ago. The zooplankton was living the same in the water. The temperature decreased with the altitude, precipitation decreased with the inner of the continent, and so on. So all the processes was the same, yeah? The hydrological cycle, for example, was the same. This is uniformitarian principle, which is very important, because based on present day processes, we can find out how they behaved in the past. And the second rule is that lake sediments accumulate in accordance with the principle of superposition. So the first layer of the sediments, they are just on the bottom of the lake, and then newer and newer. They are not disturbed. If they are mixed over the time, because the lake was shallow or because the animals came in, their hive is destroyed. So they actually silted page by page from the oldest one, which is just on the base of the lake, to the newest one, which are just between the interface between sediments and the lake. This is the newest, without any disturbance during the time. This is very important, because if the lake is shallow, wind stress can disturb the sediments. So when you look for a lake to study for the paleontological proxy, you need to look on the deep lake. First rule, a little bit, maybe not tiny, a little bit bigger, but not too much. It's important to be a big lake, a deeper lake, not too much, at least 5 meters is okay. For example, in our region, because we are here in the southeastern Europe, and I know the situation in Ukraine and Slovakia and Poland and Hungary and so on with the lakes. And if you want to have a good climatic signal, you need to climb a little bit up. So look for the lakes in the mountains. Interpretation. We have qualitative methods and quantitative methods. Qualitative methods, it's about the species, about conditions that can be characterized in different groups, and we can talk about their distribution. We can talk about their comfort, climatological comfort, to know how the beetles prefer, what kind of temperature, what kind of precipitation, humidity, and so on. And this is quantitative, and we can make graphs and so on. Quantitative method is using transfer function to establish a numerical value, because we need values, we need numbers, see, of the variable in the question. We need to put all of these conditions of the species environment into the numbers. Also, everything that we find in the lakes, like geochemical, magnetism, and so on, we need to put in the numbers to have these graphs. And this is transfer functions. They are used to establish a numerical value of the variable in question. And they have a lot of values that are connected with the lakes. So calibration sets on transfer function is simple from the species and environment data using mathematics. Yeah, simple. It's a geostatistic that you study on the geography, and then transfer function. So from the sediments, we have environmental data, species data. Doesn't matter which is about pH, temperature, oxygen, species, different kind of species, and then transfer function construction, taking long course. This means the entire course. Then we'll be able to reconstruct the past environment, such pH, phosphorus, nitrogen, species, salinity, temperature, and this is the transfer from the quantitative and qualitative indicators to the reconstruction, like we show you here, the lake system with the sediments, everything which comes, all the information from the lakes are actually put in the functions, the geostatistic, and then we have quantitative paleo reconstruction graphs. And we will see later on a lot of graphs like that, which explain the changes, both environmentally and human impact in the lakes. And this is what we want to talk today. Just a little bit, few things about interpretation of paleontological indicators. As you see from the beginning, we are interdisciplinary, so we depend on lakes, lake state, catchment status, atmosphere status, because we want to see a connection between this and to find out which indicators are important to actually go back to see how was the temperature and the precipitation in the past. But we'll start with the precipitation and the temperature because they are a factor control. Depends a lot amount, the gradient, and then regime, seasonality, and they have a lot of influence about water level, about transpiration, oxygenation level, and then we can find this by using these tools, these indicators. There is a lot of interconnection. The catchment is very important anthropogenic activities, also which can disturb the vegetation and soils, which means erosion. Erosion means clastic inputs in the lakes, so more sediments comes in the lakes. Also nutrients, because the sediments come in the nutrients, especially in the agricultural area. Nutrients influence a lot of biological activities, and then we can see that in the sediments, measuring calcium, iron, oxygen, endogen ratio, or organic content by loss of ignition, for example, to see how much organic contact we have in biological activities, and then we go back and we see how strong its anthropogenic activities, and then also here go back and see how is the precipitation and temperature. This is the interpretation, simple, of paleontological indicators, and these are some indicators. We use some geochemistry, actually chemistry, physics, biophysics, to find out what happened in the past with these lake sediments. Since biotic and abiotic interaction on the ecosystem can be very complex, we will see till now, it is necessary to work with as many proxies as possible to get a broader view of past ecosystem changes. Smaller is one of the best in paleontology research. So we need more proxies, more is possible. And I can add something new. We need more lakes, for example. It's better not to pay attention only on one lake. It's better to have a series of lakes. But from my experience, this means you need a lot of support for that. There is a comparison between the researchers who work in the Central or Eastern Europe comparing the Western or North America, they go to the field, they take samples from the 20 lakes, they go to the lab, they measure something, and they decide to stay only on 3 lakes, and then work on only these 3 lakes with a lot of proxies. We can't afford that because it's too expensive. We need to go to the field and to take a choice, and depends of the researcher to take the best choice to say, okay, I'll take these lakes and I'll go on that. So it's different. It's important to have to know a little bit about the 3 major zones in the lakes. There is a littoral zones, so it's very important for the biological productivity because it's a zone with a lot of vegetation. It's important for biologists. Pelagic zone is a zone with deeper water. A profundal zone is important for the lake sediments. So if you go to the lake to sample, you need to sample in the center, in the zone, in the sedimentation zone. It's here. Don't sample in the littoral zone or even close to the littoral zone. Just go to the center, because this is the profundal zone, and these are the best sediment profile. And then we need to take the samples, and this requires some equipment. We need boats, we need type of coral that can provide, can take, which help us to take the sediments from the bottom of the lakes. This is one of the type that we discussed today very shortly. It's about the gravity coral. It's easy. You just need to throw it into the sediments, and you can take only the surface sediment. But it's very important that you can take the interface between sediments and the water undisturbed. And these short cores are very suitable for the human impact, history pollution, at least for last 2 or 3 centuries. I have done, and I still do that with the students, and then we subslice. Piston core, it's a little bit complicated. We need more boards, maybe 2 or a better board, the tripod. Piston can help you actually. It can provide you the whole profile of the soil. It's a lot of work, but later on you can take the whole profile. It's much work to do, and it's heavy work, and it's difficult to carry a lot of equipment to the high mountains like we did in the, for example, in the Transylvanian Alps and so on. As soon as you have this profile, it's better to be overlapped, for example, yeah, one by one, to have the ability to construct the whole profile. You need a methodology, and then you need a laboratory. This is the problem in our region. Maybe within this Collegium Carpathicum, maybe it's a good time to talk about the funds, about the utilities, facilities in our universities, because without these facilities, we can't go on from this stage further. For example, in the beginning of our study, we used mostly Western laboratories. Even now, we can't have possibility for chronology, for example. Even geochemistry, a little bit, not too much, but it's better than the past. Magnetics is fine, organic content also, particular size, it's also good. But for chronology, we have only one laboratory in Romania, it's in Bucharest, and it's a young one, where we can use carbon-14. So we need chronology because we need to know when the sedimentation started and when happened the changes, progressive or abrupt changes. We need to put these changes on the time scale. We need to know when, and this is very important. And we can use isotopes, we can use volcanic ash, if we know when the volcanic explosion was, and we can use even valves if the lakes provide something like that. Geochemistry is important because, as you can see on the indicators, we are dealing with a lot of chemistry here. So Titanium, for example, tell us about the plastic inputs, and we need to to have information about titanium, iron, manganium, and so on. And we need XRF, and this is an expensive one, but we need that because this X-ray fluorescence actually provides us everything about the Mendeleev table in the lake sediments from the IA to Z. We don't need all of them. We need just few markers that we used, but this is geochemistry, and not only. We need magnetics because sediments have a magnetism. They record, they take this information from the outside magnetism. We call magnetic susceptibility, and there are different types. It is not very difficult. Organic contact is very important because it's very connected with the biological activity. It's connected with erosion, with the changes in vegetation and soils and so on. And vegetation is connected to anthropogenic activities and also with the climate. And this is important to know about organic contact. We use loss of ignition. We just burn the sediments. After we are finished with all the sediments, all the measurements, we can burn. And as soon as we burn from different temperature, we can have organic contact, carbonatic content, and so on. Just burning puts more fire, more temperature. Particle size also is important. You know that from geography, because we can have information about erosion, and especially about the extreme events. Coarse particles means a flood event, for example, and also microscopic analysis on the thin sections. Carbon-14 is very useful and very used in the sediment, lake sediments, because it's best for the last 20,000 years. You can go even deep in the time, but it's best for the last 20K, and this is best. It's very okay for the from the period between LGM, last glacial maximum, and present. It's very okay method, and if you can add some isotopes like lead or cesium on the end, you can have a very good model, age model in this case. For that, you need to take samples. We need some organics content like seeds or leaves or a little stuff like trunks or even bulky sediments with high organic contact, and then we can take samples and send to the laboratory and make sure that we have money. It's only 400 euros per sample, and sometimes can be spoiled, some of them. X-ray fluorescence, it's excellent tool. Also, it's an expensive tool, but as soon as you have it, you can measure all the sediment profile like a core, half core, or even for the thin sections. Lithostratigraphy is the first thing that you can see on the sediments after scanning, after working. You can see about clay content, silt, cores, and even sand. And the color, for example, tell you a lot of things. Dark colors tell you about the biological proclivity, soil in the stable climate regime with a lot of biomasses around. And even using the computer, we can have a diagram with the colors, which can tell you a lot about the sedimentation in winter time and the summer time, in the cold and wet climate, and the dry and warm climate. They change the color. But sometimes, if you are looking careful in the sediments, you can find interesting and new things. Like, for example, this mineral, which is called vivanite deposit. It's a hydrated iron phosphide mineral. It appears in the lake sediments, and it's not very common. You can find somewhere in the United States, somewhere in Russia, in Baikal or Brazil, but we found it in in the Bukovina, in our Millennial Lakes in Bukovina, this vivanite, we found it very easily in the thin sections, but also on the X-ray diffraction, and it's here. It's about the immobilization of the phosphorum and the ability of the sediment to retain this phosphorum in the special stage, especially when the lake is very eutrophic, so rich in the organic content and the nutrients, and then there is this possibility to trap this phosphorum as a vivanate, and it's very susceptible, and it comes out from the sediments and stay in the air. Just oxidation is very rapid, but it's beautiful mineral you can find in your lakes. Maybe you need for that to take a sample and then to thin sections and then put in a microscope, and then we can find this. And because we are in Bukovina, and because in Bukovina we have a very nice UNESCO monasteries that we can visit when you come to visit our university or region. One of the best is Voronezh Monastery, which is UNESCO heritage, and also is very well known for Voronezh blue color. And this is very fine color, and you can see there is a very nice connection between this Voronezh blue color and our vivanite. It's just a supposition. I'm not sure about the connection between these two and the technique that we don't know exactly even today how they obtain this color, because I am sure it was very difficult to find this color in the lakes. But as a connection, chromatically, it's very interesting comparison between Voronezh blue color and vivanite, which can find in the lake, and we can tell you about the trophic stage of the lake. If it's phosphoric rich, then we can find a vivanite. But it's not very common, as I said in the beginning. So we are glad that we found this very nice mineral that has a story. Also, these lakes that we talk just a few seconds away, it's mini stratificated. It's somehow laminated. It looks a little bit like a valve, and this is very important for reconstruction. If you have this stratification in your lakes, this is very good for the environment reconstruction, and we found that. And you can see even within these layers, you can find more layers. This is minor stratification. Every layers can tell you a story about decadal or multi-decadal time. Our Bolotov Lake, actually Bolotov, it's a Slav term. I saw most of you are in the Slav area. You can understand Bolotov, Balaton. This is the Ezer, for example, also comes from the Slavic language. It means actually lake, because we are also in the northern of Romania with a Slav influence. So we have also Bolotov lakes, not only here, but also within Romania. It's a tiny lake. It's in the spruce forest in the Bukovina. There is at least 3 lakes there. We call Millennial Lakes, and it's an old one. It's the oldest lake in Romania, landslide dammed lakes, which have water, because there is some of them, but they are completely silted. So we need to protect it very much because it has a story. So this lake can tell us all the changes that the environment or climate have experienced in Bukovina. Okay, we come deeply, but not too much, because it's a presentation for students, just to learn and to learn how to put these indicators face to face with the environment and the climate changes. This is geochemical stratigraphy. We need lithology. You can see here, different lithology on the problem. Here we can use ages based on the carbon 14. You can see the ages is just here. We have half of the Holocene. This is not for the Bolotov, it's for another lake. We'll talk a little bit later. And we have a lot of measurements based on the geochemistry, like potassium, iron, carbonatum, and ratio, organic mineral ratio, lead, titani, and degree of variation. All of these indicators tell us information about erosion, like this one. You can see the changes in erosion during the time. We can tell us about the carbonates during the time. Yeah? Tell us simply about the particle size, granulometry, and this depends a lot about the climate change and human impact. You can see here a big human impact at the end. For all of these indicators, this is very clear of the human impact in the sediment lakes, both in the detrital inputs, increasing core sediments. You can see here, yeah, carbonate is also increased. Lake productivity, you can see here, changes very little in the beginning because this was a baby lake with no very big lake productivity, and then increased a lot when it was warmer maybe, and then changes, and even on oxygen level changes. So this data actually, this is the interpretation of the paleogeometrical indicators in order to describe the environment and climate changes. Variations are different. Moderate in the beginning, because the lake, it was just formed, and then started to appear some changes, and then weak, just a stabilization of the lake, and even weak on that, a little bit moderate, I would say, and then strong. This is the last phase with the human impact. So this is how we can interpret these indicators. Also, magnetic stratigraphy is important. We can see degree of magnetization, not very important at the beginning, and increase more and more today because the human impact and coarser sediments that comes into the lakes. And this is tells our magnetization of the sediments. Also, with the fine magnetics, mineralogy, granulometry, undergraphs tell us history about environment changes, especially erosion. This is Lake Giel. It's in the karstic area, also landslide lake. Also, it's like a Boloteau, half of Holocene, the second half of Holocene, and you can see all these indicators, and then we can see interpretation, paleoclimatic interpretation here. Usually, paleoclimatic interpretation use system like a humid, dry, warm, and cold, and then we can have some, events, for example, like industry, human impact, agriculture, deforestation, and so on. But based on these indicators, we can have this paleoclimatic interpretation for the half of Holocene in the Optimum mountains, because this is located in Optimum mountains. And then we have these 4 stages with the lake basin formation in the beginning, very intense erosion processes. Yeah, you can see here, because it's a new entry in the environment and the landscape in the new lake, and then the erosion is very, very, very strong, low productivity in the beginning, and it's the same for the mid-Holocene. And then basin stabilization is a transition condition, oscillation, detrital, natural flow with the floods, time to time, productivity increase. Basin became stable here because erosion decreased a little bit and increased the productivity. And most important, the last stage with the basin destabilization. And you can see these peaks here in different direction, which means oscillation, biological activity, and human impact. And this is how we interpret these indicators for the paleoclimatic reconstruction. This is samples from these big lakes in the Optimum mountains, and now we come back a little bit for our Millennial Lakes in Bukovina. They are located either the same Slav name for the lake, and the Boloteau is here. The tiny lakes are walled, and the forest in Bukovina, which actually in the past it was fir trees, but now are dominated by spruce, because the Austrian canes and also they saw some Bukov trees, which is a beech tree, sorry, and now we can see very few Bukov tree or beech tree because disappear, because they are removed by cutting, also the climate changed, and now we have spruce in the Bukovina. But you see in the beginning we had a lot of fir trees in this region. Also the same for this Jezeru Sadovej, which is it's a younger lake. It's 1,000 years old. It's very important for the climatic reconstruction for the last millennium in Bukovina and northern Romania, with also these indicators, that geochemistry and also organic plant macrophysi, pollen also we use for that. And we have these three important phases based on the climate. We have medieval climate, warm climate, this part, okay, which is between, in our case, between 1,000, 1,200 years ago, yeah. And then we have even more with another phase, and then we have Little Ice Age, which is colder and wetter here, and modern, the last phase, including global warming in this part. But we have also these historical stages with the Austrian-Hungarian regime that we discussed about, because Hungarian came here in 1775, and they had a different kind of view of forest management, which affect our forest and Jezeru Sadovej also, and recent times that you can see with human impact and changes in the vegetation, as we can see. This is our lakes. It's a beautiful environment, at least since few years ago. It was a bigger lake in the beginning, at least 2 hectares, and now, at least few years ago, it was less than one quarter of the hectare. But because we have this tendency to exploit, to make a better touristic activities in the area, we destroyed a part of the lakes down in front of the lake to make like a little touristic resort, which I was very pity. I tried to save this site. I saved this accumulation zone, but not this in the front. They constructed new dam, and now it's there is a lot of construction around for the touristic activities. There is only one good thing for that, because we didn't know that on the bottom of the lake, which was 4 meters deep, they still exist these trunks, these very nice trunks, all of them with the same inclination, because the landslide came from this part and pushed the forest upstream. All of them are like that, and all of them, they are fir trunks. So this is why I told you that the vegetation, it was different 1,000 years ago, because now we talk about spruce around, and also these trunks we could sample, because the lake level was lowered for provide the worker the space to drain sediments in the down in the front of the lake, and we took slice of fir trunks for the dendrochronological reconstruction. This is the new step in our paleoclimatic reconstruction. And in this case, I can make you a comparison between our very well-known Red Lake, which is not far away from Bukovina. It's close to the Vikas Gorge. Still, we can see these trunks outside the lakes. It's a baby compared with our lakes. It's only 183 years old. But here we can see the comparison between these two. This is an example of how we can destroy our lacustrine environments. So actually, our goal for climatic reconstruction with the lake sediments is just to put some information of these graphs that are based on analysis of oxygen isotopes in the ice cores in Greenland, for example. So usually we are here, starting from Atlantic to present, with a wet, cold, warm, drier, wet, cold, because it's Atlantic Sea, and also to get information about medieval period here, about the Little Ice Age and modern time, especially if we talk about the Ether, which is only 1,000 years. But also, if you have half of Holocene and the sediments, we can talk about climatic Optimum Holocene. We can talk about the warm period during the Roman Empire, or cold condition during the Germanic migration, for example. We can get information. So if we go deeply in the half of the Holocene, we can see that temperature and moisture changes during the time, and you can see the temperature was lower during the Little Ice Age for a short time, few centuries, but enough. Yeah, and now all of them increasing. It was an optimum somewhere here, a cold period that we talk about in around 3.5 thousand years ago, and also optimum about here. So this is quite a good synthesis of different lines of evidence of beginning to produce consistent records of Holocene climate change with pollen, chironomid, isotopes, and even the water level in the peat box. So there is more proxy data for these graphs, just to have a picture of the climate change in Europe in the last 5,000 years. And now we are coming closer and closer on our present time. It's not an accident that we have presented you the nuclear explosion since 1945, because we had a lot of experiments for the nuclear weapons over the world, especially made by the big nations like the Soviet Union, United States, Japan, China, France, United Kingdom, and so on. What is important that is we had a peak in 62, 63, and then because it was a treaty, they gave up because they realized that it's very dangerous. Some nations like China or France, they still go on, but they finished with that. And then we had another example of this with the Chernobyl in 1986. Also, big environment accident. Is one of the worst in the world. And what they are, and then it was another one in Fukushima in 2011. What is are in during the 1986? They put a lot of isotopes in the atmosphere, and they deposit on the ground. And you can see a map with this quantity, not too big. They are not harmful, at least now, not in the past. They are harmful when they are in the big concentration in the air. As soon as they deposit, they are okay. But they deposit on that time in 1986, and we can find everywhere in the northern atmosphere, especially. And what are we're talking about that? Because we can find these events like experiment of weapons nuclear with its peak in 62, 63, and also with a peak in 86 of Chernobyl in the sediments, in the lakes, everywhere in the northern atmosphere. This is the volatile. So we can see the weapons nuclear peak, it's buried about 12 centimeters, and the Chernobyl is buried about 6.5 centimeters. So we can have a very accurate sedimentation rate if you want to calculate in the last 60 years. But it's this is the good part of this very harmful experiments and accidents, that we can use the cesium 137. This is the very common during the weapon experiments and the Chernobyl and the nuclear plant explosions. They are it's released and it's everywhere in the atmosphere. So we can, and you can see the peaks very, very easily. It's not harmful for the organisms or the plants within the lakes. It's just very few quantities, but you can see very easy. This is very important for the rate sedimentation in the last 60 years, and this is a very good tool. Also, using these Jesus peaks, we can have a better age depth for our lakes. Another isotope which is very, because you can use carbon-14 for the events that had occurred centuries ago or millennium ago. But if you want to look maybe in the last 1 century or last 200 years ago, carbon-14 can't help you. So we need another one which has a lower rate of disintegration, like it's lead 210. It's very important to see what happened with our landscape, or especially our terrain in order of erosion. So we study lakes, mostly up in the mountains, in the higher altitude, in the lower altitude, and also in the plain, to see what happened with the rate sedimentation in the last 200 years, and using gravity cores, and we find an increase in sedimentation. You can see very easily using these magnetics, for example, in the lakes. This is the Glacial Lakes. This is another one, is the Glacial Lakes, and also in the volcanic lakes, and then the others, for example, in the Catahol Lakes of the Transylvanian Alps, no big one, so there is no increase in sedimentation because it's well protected compared to the others. These two lakes, like Bucărescu, Mare, and Stiol, they are facing even today a very harmful actions, because the human impact. We like this modern entertainment using cars and to go close to the glacial lakes, and it's not only about that. Also, we are in Anthropocene, for example, even in the glacial lakes, because we can find lead and zinc in the glacial lakes sediments. Again, they are not harmful, but they are very important tools to tell us that the atmospheric pollution has a signal in the lake sediments. And this is because the industry and because the our cars, especially when we used leaded gas a few years ago, for example. So even in the glacial lakes, you can find lead. Not too much in the northern of Romania, so close to Ukraine border here, in the Maramureș and Rodna mountains, but more in the Transylvanian Alps, because the heavy industry in the Transylvanian Basin and also south of the Transylvanian Carpathians, and we had a very big, heavy and polluted industry during the socialist time, as you know, because most of us belong to the socialist era, had the rest of this socialist era. And the wind, which comes through the west, southwest. So all this, you can see industrial area put this lead and also another chemicals in our lakes, especially in the Transylvanian Alps, less in Maramureș and the Rodna. So this is explanation and conditions, and this is why we have these heavy metals even in the former glacial landscape. I will give you an example of disabled lake, for example, in case of glacial lakes. Glacial lakes, by default, by name, it's a very well protected area, because glacial lakes means a heritage. When you talk about the glacial lakes, immediately you go back with your mind in the Pleistocene, because they are from Pleistocene. They are survivor from that. So this means that we need to protect in their barrier. If they come from Pleistocene and they resist till today, means they are natural archives. So they have all the information during the Holocene, because the glacier disappears, they left behind the basin, maybe a moraine in front of it, and then the water comes along with the sediments. So we need to protect very much. But it doesn't happen in Rona mountains where these lakes exist. Very nice, tiny, like a tear shape. And then another one, mayor of the town nearby came with the idea to have a little touristic resort in the national park. It wasn't on that time, it became national park in 2004, but anyway, in the glacial area, and destroyed and spoiled the area, and actually modified the lakes from that shape to this shape. It looks like a pond. You agree with me? This is like a pond looks, with a dam in front of it, and change the depth, the shape, the size. The size shape changes 18 times, for example. And artificial elements like a dam appears in the very glaciate environment. This is one of the greater impact on glacial lakes in Europe, maybe in the world. It was a disaster, ecological disaster for naturalists like I am. And this has happened when the human try to destroy a glacial environment. You can see these peaks, yeah, because we took samples few years later, and we discovered very easily these peaks in the lake sediments, like a signal of the human impact, very clear in the magnetics, for example, in October 2002. And we published a paper. Finally, because this is the last item of my presentation, because I study a lot of glacial environment, glacial landforms, glaciation in the Romanian mountains. Also, later on, I paid attention of the glacial lakes as hydrological, item for limnology, and then for paleolimnology. Also, I used proxies in both processes, like lake sediments and then glacial deposits, to have a picture about the climate change during the last 20,000 years ago from the LGM. So this is why I pay attention for the glacial basins, where are the most significant morphological features in our mountains, like a glacial heritage, as I say to you. Beautiful lakes. They are quite the same like in Tatry mountains or like in Pyrenees. Maybe in Tatry some of them are really big, like Morski Oki, which is almost 80 meters deep, and some of them quite large, but ours also they have good numbers. And because I visited many mountains around the world, including Himalaya or Canada, North Canada, Northern America, South America, but I was interested mostly in the North America to see what the Carpathians looks just after the glaciation. And one example I found in the coast mountain nearby Vancouver in Canada, and I saw there how the Carpathians looks just after the Pleistocene, after the glaciation. And I can tell you that we have now in Romania 270 lakes, which is actually lakes and peak box with lakes and so on. And I am sure that they were even more, because some of them disappeared because they were very close to the head wall, to the slope. And if you are very, very, very short, very close to the head wall, then you have the possibility to be burned by the debris. And this happened with the lakes. It's happening with the lakes and the coast mountain. I see that some of them burned half, some of them completely, and these lakes they faced a lot of changes during during the last 12,000 years, but they survived. Some of them disappear completely because they are covered by debris, especially if they are close to the slopes, as I said, because the slopes became very, very unstable because this glacier disappeared, and a lot of rock falls and rock avalanche and rock slope failures came from these slopes and covered everything what was nearby. Some of them reduced by size because it's a sort of erosion, and some of them remain like a peat bog, silted completely and became peat bog, and peat bog with pool, with a little pond, say. But we have these 270 lakes in Romania, along with 631 cirques, which I studied when I finished my PhD. So it was a huge work. Glacial Lake distribution is one. It's unbalanced. This means that most of the lakes are in Transylvanian Alps. This is the this is real. How we call Southern Carpathians. Especially when the mountains exceed 2,200 meters above the sea level. But we have also some of them in the northern Romanian Carpathians, close to the Ukrainian border and Roda and Maramureș. So we produced the first and also interactive map of glacial lakes in Romania. So Romanian Carpathians is the only mountain range in Europe which have this map, which comprises all the glacial lakes in Romania mountains. We want to do that for the whole Carpathians. We work with the Ukrainians, Slovakians, and Poland researchers, and we will do that for the whole Carpathians. Even we have a online database if you are interested to look on them. And every range, every mountain range in Romania has this map with some numbers and fractions and toponyms and so on. I explain you because it's very interactive. For example, our bigger glacial lakes in Romania is Bucura Lake in the Retezat Mountains. It's almost 10 hectares as a size, and I think we can read here 9 hectares you can see, and 15.7 meters deep, because these numbers tell you about the size and the deep, and the number in front of the fraction tell you about the ID. So every lake in Romania has an ID, and also the cirque has an ID. So you can see, you can find the location very easily, because sometimes toponyms, Bucura is very well known, but sometimes some toponyms are similar or somehow not very accurate, and it's better to have this ID. And I suggest to you to use when you work with many items. So now we can locate very easily where the lake is, within which cirque. For example, this ID number 469, and you can easily go to the map of the cirque because there is one like that. And you can find on this database even GM model with the lakes and information about the area depth, even pictures about the lakes, like you can see here. And Retezat Mountains, which is in southwest of Romania, it's our most beautiful mountain region in Romania, because the granite fields you can see here, and also because the beautiful glacial landscape and the beautiful and most glacial lakes in Romanian Carpathians. 65 are only in Retezat Mountains, accommodated in the 85 glacial cirques, because only one of two there are glacial valley, we chop later on. And then you can find even information about geology, about the glacial history with the ages, about the glacial retreats, picture, even about vegetation history if they are studied, because if you see glacial lakes are used for the about the vegetation distribution and history and bathymetric maps. So this data set can be improved by anyone who can add information, and also we can do that for your part of the Carpathian, because we are in Collegium Carpathicum, as you know. Most of the lakes and also cirques, but in this case we talk about the lakes. Maybe next time we'll talk about the glaciation and the cirques, because we have a lot of results in that direction. Most of the glacial lakes are located in the southwest of Romania, and this group or mountains, because even today they have more precipitation compared with the others, because they have influence from the Mediterranean Sea and also better influence from the Atlantic, and this is important for the glacier dynamics. We had here more dynamic glaciers with warm glacial base, so they slide it very easily, and they can construct this basin. And also because the rock is important for the rock basin, for formation of the lake basin, and granite has this susceptibility to form rock basin, because we founded that in Retezat, in Parung, in Tatry, and also in Pyrenees the same, and we'll talk about that. Just a few words about the size, altitude, depth, and area. This is the number. You can see the mean altitude of our lake. So if you are around 2,000 meters in altitude, you can find glacial lakes for sure. The depth is 2 meters, the average, not too much. So there is a rate of sedimentation quite fast, at least in the beginning of Holocene, and area it's around 5 hectares. These are our lakes mean statistics. There is a big correlation between the depth and area. The greater area gives greater, the lakes are deeper. So you expect that bigger lakes to have a deeper water. Okay, this is a correlation. As the types, I can tell you a few things. You can see that 2/3 of the lakes actually they are shallow lakes, peat bogs with pool and something like that. So 66% of the lakes are actually shallow lakes and peat bogs, and the rest 1/3 they are minor lakes, which are between 1 and 2 meters deep, and lake we call normal lakes between 2 and 5 meters deep, and major lakes only 10%, 12% with the lakes which exceed 5 meters deep. As a type compared with glacial landforms, most of them, 95%, they are glacial cirque lakes. So they are located within glacial cirques. There is very few in the valley, and only one very interesting type that maybe you can have in your Carpathians, but we discovered it's a Catahol Lake. It's rounded. It's only one in the Rhoda Mountains, not very deep, 3 meters deep, but it has a different story. This formed differently compared with others. It's about the trapped ice, because when the glacier retreats in this way, when the glacier retreats like an army, some part of the army, because it's an unorganized retreat, like happens usually with the army also, some corps of the army, some corps of the ice remained behind, like big boulders, let's say, and they are buried by clasts, because when the glacier retreats, a lot of clasts come from above or from the each side, and these big boulders of ice remain buried in the moraine, like here, and they are melting progressively during the Holocene, and then when they melting completely, this glacial crater, I would say, appears. This is Catahol, special for the North America, not Alaska and Siberia and so on. But we have only one in Romania, and I wanted to mention that. And it has a different story, and it has a very important. We didn't study paleolimnologically because we interested when it has appeared, so we can find out when it was the peak or warm peak in the beginning of Holocene. Because, for example, he appears when there was very warm in the beginning of the Holocene. As I said, most of the lakes are the cirque lakes. They are within the cirques, this big amphitheater. Okay, few of them are on the valley or the valley steppe lakes, and actually they are in Reconstruction mountains like this one, which is a series of lakes on the valley head and the cirques and the valley steppes, which they are known like paternoster lakes because they look like a rosary. Yeah, this used for the prayers. Beautiful also in the granite environment. And when we talk about granite, about geology, I can say that 60% of our lakes are in the crystalline schist, the different kinds. Yeah, different kinds, the mica schist mostly. 1/3, actually, 30%, actually 1/3 of the glacial, and one of the best, largest and deeper and beautiful, and also good for environment signal because they are on the granite. And this is important to mention because the deepest and the largest and most of the major lakes in Romania are in the granite fields. Because, as I said, on granite, they are very susceptible for over deepening by the glaciers. Because I think the stratification is missing, and it's easier to have the basins compared with the crystalline schist. And this is why we have a lot of lakes in Paring, in Reconstruction, and Transylvanian Alps, and then in Tatra Mountains, and as I said, in Pyrenees. Rest of them, they are staying on the sedimentary rocks, even on the limestone. Few of them just in Transylvanian Alps. Okay, these are some reference for paleontological approach. There is some papers and books. I recommend you, if you want to go deeply in this field, to find John Small, because he is like a modern father for paleolimnology, or paleolimnology. Also, it's important to apply for small grants, or to use the Erasmus program or this Collegium Carpathicum for exchange, because I think the next step in this Collegium Carpathicum is to exchange students or professor to work in the field and in the labs also, because also to share knowledge and to share, methodology and techniques in different kind of fields. And this could be one, because we share the same Carpathians with the same paleoclimatic signals, with the same environment issues today, like pollution, deforestation, destroying the diminution of the biodiversity, and so on. And this will be fine I am happy to share that in the field also. And I hope you understand a little bit, and I was able and managed to open this window to the past, for you, as a key for our future, because we need to know what happened in the past with our climate, with our environment, with our sins, because we have a lot of environment scenes, yeah, like weapons testing and accident, and today industry, heavy industry, fossil fuels that we use very much, and this will affect our future for sure. And we are facing already this, because this virus actually, it's depending a lot of is based actually on the environment degradation, because we destroyed a lot of amount of the biodiversity. We put a lot of greenhouses in our atmosphere, and then affect very much the life on our Earth, starting with the teeny organism. And this is a good example. We still doing that with our students, and we have a lot of connection in Europe, working on different labs, sending students like Erasmus, applying for funds. They are not too much, and we are happy to share and to work with within Collegium Carpathicum. Thank you very much.
Thank you a lot for so fascinating and interesting lecture. Thank you, Professor Mîndrescu. Is someone have some questions? Okay, if we have no questions, then I can say that this lecture will be, you can find it on YouTube, and the link we will put on this page of the Collegium Carpathicum on Facebook, and also you can find the record of this lecture on the page of University of Warsaw. So I thank you again, dear Professor, for your lecture, for interesting information, even for those who are not biologists or ecologists, or
I'm sure, yeah.
So thank you, and
I thank you very much. I hope I was able to transfer some knowledges that we had gained during the time, and also I gained these skills working in my home university, and also on the host institutes in Europe. Also, I'm very willing to work with students from my home university, or from Carpathicum consortium, say, institution also, if they are interested in such collaborations in Collegium Carpathicum. So I would like to thank you very much to the students that they pay attention to my presentation. And if you need to find more about this field and about our result and how to work in this field, you can contact me. I provided an email address, and you can contact me directly if you want to work on this field for dissertation or for PhD thesis and so on. Okay, I'll be very happy to help you.
Thank you a lot.
You're very welcome.
Thank you for your proposition. Yes, thank you. And one more time, I want to say that
you are from Ostrava.
What?
You are from Ostrava University.
Yes.
I see. Okay.
So, and one more time, I want to say that this lecture you can find on YouTube and on our page of University of Warsaw, and of course I will publish this information once again on a page of Collegium Carpathicum. Thank you again, dear Professor. Thank you. I will end the meeting if there is no questions, and I hope to hear you again and to meet you in the frame of our project.
I'm looking forward.
Thank you.
Bye-bye. Thank you very much.
Thank you. Goodbye.
Bye-bye.
Goodbye.